Okay, hello everyone. I'm talking to an empty room here, but I came in on Sunday to make a video to help people out getting started on Project 3. I tried doing it in my office, but then things I wrote on the whiteboard just were not visible. So I came in to use the room here in IOE because we can only set up recordings in rooms we already record in. So I've got a list of things I want to talk about. I've made a list here. So first of all, what is the project about? So the project is about managing logs. And many times programs will produce logs of things that they do, possibly that go right, many times things that go wrong. Rather than displaying them to a user who cannot deal with them, it'll log it to a file, and then someone whose job it is to keep every system running might go through and look at this log file and try to find the things that are important to different people. So I might have to look at, say, I've got to find all the network errors and give that to the network group, and I've got to find all the server errors and give those messages to the server group. So the program reads in a log file and then processes commands. The log file is going to be specified on the command line, and it must be. So you'll always have /logman and then a file name like spec-test-log.txt. After that, you're going to, or sorry, I should say for that, you're going to use a file stream object like you used in 280, open the file, and you should print an error message. If it doesn't open, just for your own sanity, the autograder won't test that. But if you forget to run it with a file name, you'd rather see that you forgot the file name or you typed the name wrong rather than finding a segfault later on. The next thing is the commands. The commands, you could type all of the commands in by hand, or you can redirect it from a file if you want. So you could pretend this is all one line. We could say less than spec-test-commands.txt. So that part is optional. We can type commands if we want, and in fact, it would be good for you to sometimes type commands by hand to try out different things, especially when you're first starting to get the project working. You don't want to run 20 commands in spec-test commands, 19 of which or 18 of which aren't implemented yet. You'd be better off loading the log file and typing a command by hand. Either way, you're going to read the commands from CN just like you normally do. If you're working on Xcode, you will need the Xcode redirect in order to read from CN, but that's not required for the autograder. Next, let's talk about where to begin. Well, obviously, reading input. Now, the prompting the user and reading input, I see students all the time who do this painfully, make it more painful than it has to be. The right way to do this is to use the do-while loop, which I know because I taught 183, at least it used to be taught in 183, and if you're not getting it from other places, you'll get it from us. It is in the Canvas Files Resources Optimization Tips document. There's a section on reading input. Now, since we know that the user must enter at least one valid command, which would be quit, we know that since they have to type at least one command, our loop is going to have to run at least once. So I'm not going to control my loop with reading input. I'm going to control my loop with did they type quit. The beauty of the do-while loop is that the do-while loop starts out with do. There is no test for should this loop run. This loop must run at least once. Do. Cout a prompt %space and then cin into, let's call this, let's just say cmd for command. That's enough to read the just say it was a character. That would be enough to read one character from there. And then we can get the rest of the line later on. If you want to, you could instead make this a string, and then we could use get line here. Either way will work. If you get line the whole line, you will find later on you have to chop it into pieces. It works. There's, I should talk about reading the log file. We'll get back to that in a minute. So the nice thing about the do while loop, whether you read a single character just to get the command letter, or whether you get line to get the whole line and chop it into pieces, either way, we can do this, and then we would do other things like process the command. Then at the end, we say curly braces, while, and I'll write it as if it was a character, while CMD is not equal to the single letter Q. That's how long the loop runs. If the user doesn't put a Q command in the log file, or sorry, in the commands file, and they redirect the commands from standard input, then this program would have problems. It doesn't have a way to detect that you stopped giving input without quitting. If you give the autograder a commands file that doesn't have a Q at the end, we will reject it. We'll say that's an invalid command file. It's supposed to have a Q at the end of it. Okay, so that takes care of reading the commands. Let's talk about reading the log file. When you read the log file, you can use getLine is definitely the best approach because every line goes together with a log entry. You can either do getLine with the whole line and then chop it into pieces as needed, or you can get the pieces one at a time. And the way you do that is there's a version of getLine. So let's say I have string. If I had string line, I would just do getLine, or actually probably I would do while getLine of CN, comma, line. That would be my while loop if I want to read the whole line. However, if instead I want to break it into pieces, let's say I've got string, let's see, so what comes first? The timestamp, let's abbreviate that, TS, and then the category, and then the body of the message. All right, so there's my three pieces. What I can do here is I can say while getLine from CN, comma, timestamp, comma, there's the third parameter here, single quote, vertical bar, single quote, and then we'll close our parentheses and our curly brace. While I can read a timestamp, it will read up to and including the vertical bar. It will throw the vertical bar away. It doesn't become part of the string. And then inside of the while loop, I could do another getLine from CN, comma, the category, comma, vertical bar, and then I could just getLine CN, comma, message. And nothing else because that'll read until the end of the line. So you can use either one of these methods to read the log entries, depending on whether you want to get the whole line and cut it into pieces yourself, or whether you want to store it as, read the pieces and store them separately. You can make the project work either way. You're going to need a data structure to represent this log entry, and you're going to have a container full of log entries. Okay, so once we've got all of our input read, so we've read our log file, we've read our first command, where should we start coding? Well, better start with the Q command. If we use this do while loop here, we're basically done with the Q command. It can quit. All right, well then what do we do after that? Next easy command to do would be the number sign command. Number sign is a comment, and it will always be number sign space. In project, I forget which one or two, the comment character might not be followed by a space. Here it will because all commands must be followed by a space. So if we read the number sign, we can just get the line, the rest of the line, and throw it away, and we do nothing else. And if we do that, if we do it in the processing the number sign command, we do a getLine and nothing else, we will go back through this while loop. Because it's not a Q command, we go back through the while loop, we prompt the user, we read a new command. So Q and comment are easy. Where should we go after that? We need, oops, I made a list over here, my screen's going to sleep. We need something after that that will produce verifiable output. So after that, I would suggest either, so let's just make a list down here. So commands, whoops, I got 2 D's in commands. Anyway, so commands, we want to do the Q command, number sign, and then you want to do either A, T or M, or C. One of those 4 commands, and I would say probably the easiest order to do them in would be A followed by, really T and M are really, I was going to say M is a little bit easier, but it's not. Because both T and M are going to involve searching for the beginning of the timestamp, the end of the timestamp, and then C is going to be a bit more complicated. We can get all of these commands done with no data structures other than a container full of log entries and lots of linear searching and sorting and stuff like that. It'll be slow, but you can get right output. But let's talk about optimization later. So I'd get one of these commands working, either A or T or M or C, get one of them working, and then write a command that will allow you to see that the previous command not only gave you like the right feedback, like I appended this entry, or my timestamp or timestamps search found 12 entries. Better yet, we want to know, did it get the right entry or the right 12 entries? So after that, I would write either P, the P command if you did A, or we would write the G command if we did any of the others, T, M, or C. So the P command says print the excerpt list. The T, M, or C are printed. G is the command is print the most recent search results. Now let's talk about excerpt list. I forgot that. I actually wrote that as a topic and then, oh no, I put it later down. So the idea of the excerpt list is that when you are the user of this program, when you are finding things that are interesting, say to the networking department, you add them to the excerpt list. Think of the excerpt list as your scratch pad of, this is important. If it's important, I put it in the excerpt list, and then at some point later, I'll print that excerpt list in its entirety. Maybe I will copy and paste that into an email, send it off to that department. Then I will clear my excerpt list, and then I'll go on to a new command, a new set of commands to search for data important to some different department. Think of the excerpt list as your scratch pad. There are a couple different data structures in this project. At the bare minimum, you need the master log entries, what you read in from the file. You need the excerpt list, what you think is important, and you will need, eventually, most recent search results, which would be a T or an M command, a C command, or a K command, which we haven't talked about yet. Those produce recent search results. Now, I could do things like I could say, hey, I do a timestamp search, from this range of times, and I'd use the G command to print out my most recent search results. If there's nothing interesting in there, I could do a different search, and it will wipe away the most recent search results. So any T, M, C, or K can wipe out the most recent search results and produce a new set of most recent search results. So basically we need a data structure to maintain those most recent search results, and we get rid of it if we see something that will get rid of it. If someone does a timestamp search, or a C, or an M, or a K, that is a valid command but produces no results, then the most recent search results would be empty. Say I do a category search for disk fault and it doesn't come up. Well, then if I say print the most recent search results, it should print nothing because there were no disk fault errors. The only time that a command might not clear the most recent search results would be T or M that is not followed by a valid timestamps, 2 timestamps for T or 1 timestamp for M. You don't have to do a lot of verification there. So for T or M, the only thing you have to check for, M must be followed by a space and then 14 characters. If there are 14 characters after the space, you assume it's a validly formatted timestamp. For T, the timestamps search, where you give it a beginning and end time, it would have to be a space followed by 29 characters. The middle character has to be a vertical bar, And other than that, you don't care. You don't have to check if their digits or colons are in the right place. But if someone did an invalid T or M command, invalid meaning the stuff there wasn't the right length, or for T was missing a vertical bar at the correct position, then you would not clear the search results because the user didn't enter a valid command. But if I did a T or an M from a range of values, and the range is always inclusive, exclusive, if we do a range of values that turns out there are no timestamps in that range, that would clear the search results. Okay, so where do we go next? So let's get something working, either A, T, M, or C. Let's get, once that says that it's right, it says, oh, I found 12 entries for a T or an M or a C, or A says I appended log entry 3. Once those are working, we get something to verify that those work, to see that it didn't just say that it did it, but it actually did do something and give the right results, either P or G. And then after that, I would say, hey, once I've got anything that creates a search results, so at some point after T, M, or C, I'm going to want to do the R command. The R command says, whatever the most recent search results are, append them to the end of the excerpt list. So if my excerpt list has 3 entries and I do a C command that comes up with 12 more, and I type R, there would now be 15 things in my excerpt list. The original 3 followed by the 12 that came from the category search that was appended. Okay, so once I've got the R command working and I've got ways to get things into my search results, then we can write a bunch of things that modify the excerpt list. Such as D says, delete 1 entry from the excerpt list. B, move an entry to the beginning of the excerpt list, one that's in the middle somewhere. Move it to the beginning, move 1 excerpt list entry to the end. L is clear the excerpt list, that's a letter L. So L is clear the excerpt list, that should be super easy. And then S is sort the excerpt list. And so, and also P if not done yet. So if we haven't done the P command, we would definitely want to do it now so that we can see the results. Okay, so after all of those are done, I would just finish all but K. So the exact order here isn't critical, but think about, hey, if I write this command, will I have some way to verify that it really did do what it was supposed to do? So if you've got like C or M or T and you don't have G and you don't have R, then it's hard to verify that it really did do what it said it did. So you can build this in stages, get all of those working, get everything up to K working, and then write the K command. So the keyword search is more complicated than the others because it has to, not only does it have to match what it's searching for against every word in every log entry, but it also must be able to accept multiple keywords and produce a list of all the places that all of those words occur together. And so when you start working on K, what you're going to want to look at is set intersection. Now remember, together earlier in the semester we wrote set union, but really set union and set intersection are part of the STL. We want to use the STL to do this. When you do it, look back at the video. I don't remember the name offhand, but find the lecture notes about when we did set intersection. I know it was with the STL lecture. So it would be in the STL lecture, it would be one of the days we did the STL lecture. So look back at that example and how I talked about how to use set intersection, how to either pre-size and then shrink it back down, or how to use a back inserter so that the results will grow automatically. Okay, so then all of those things, once we've got all those things working, we can verify that we get right output. And if we haven't optimized yet, that's okay. Now let's talk about optimizing. So at some point, you're going to want to do this. If you don't optimize up front, it will take a little bit of rewriting in places, but it shouldn't be too bad. But let's talk about it. So one of the things in the project spec that it says is we don't want to sort too much. We don't want to copy too much. Well, don't copy too much means there's only one copy of the log entries. They are in the master log file variable, whatever that is. Could be like a vector of structures, would be just fine. We don't want to have multiple copies of those log entries. Everything else, like the excerpt list, most recent search results, should refer to the master log. The other thing it says is don't sort too much. We want to sort whenever the user types the S command. Where's my S command? So whenever the user types the S command, we must sort the excerpt list. Other than that, there should be one time where sort appears in your code, and it should only get executed once, and that's somewhere near the beginning. Somewhere near the beginning, you want to sort the the master log. You want to sort the master log. You want to sort it in an order that makes everything else easier. And if you look at all of the commands that do searching, T and M, C and K, must produce results that are in timestamp order. So near the beginning, like before we process the first command, we should sort the master log file, and then we use that sorted master log file. The idea of this project is we are going to do a bunch of data structures that will make commands faster. If we don't do much other than the excerpt list, the search results, and the master log file, we will end up doing a lot of linear searching and a lot of sorting, and that's going to take a lot of time. So instead, we want to sort once up front, and we want to make some other data structures that will make some of the complex commands simpler. So for instance, if I do a K command without any data structure to help me, every time the user types K, I must scan through every word in every log entry to find out if it matches this word that I'm looking for. And if the user types 5 words, maybe I have to do that search 5 times through all of the log entries. Instead, what we'd like to do is once, at some point before the first command is processed, we want to get ready for the K command. We want to get ready for the C command. And if you look at, I'm going to bring it, let me check here on my computer. If you look in the files that I gave you, the sample files that come with the project, if you look in the README about timings in the samples, you'll see that the all commands took about 1.077 seconds. However, just the Q command, just loading it up, the log entries, and quitting the program without any execution at all was it's 0.101. However, if we look at other commands, not all is a bad example because it does lots of things. If we look at like let's say the C commands. So C commands is, let's cross out all there because all is a lot longer. The C commands is 0.113. What that shows is that basically loading the log entries and quitting and doing nothing else took almost as long as processing a bunch of category commands. That's because after the log was read, I sorted it, I got all my commands ready for things later on. Now, I've scheduled this recording for 6 minutes, so we got to hurry up here and finish. For 30 minutes to begin with, 6 more minutes. So when we talk about optimizing, what we want to do is we want to use an unordered underscore map to make things like C and K faster. Do we have to fill up these unordered maps? And I say maps plural, one for C, one for K. Does it take time to fill up those data structures? Yes. It takes O of n time. I've got to go through every log entry to get these unordered maps ready. But if I take that O of n time to fill up these two unordered maps, the first C command breaks even on my time. The first K command, I break even on that time I spent preparing for the K commands. And every command after that becomes very fast, on the order of potentially O of 1, or maybe for the timestamps search, T&M, log n, because we're going to do binary searching, think STL. When you've got to do T&M, STL, remember, has lower bound and upper bound. They're both important here. Learn to use them. So we get those unordered maps ready. What are their types going to be? Well, if they're making unordered maps for C and K, then those unordered maps, the key type has to be a string. The value type is we want some way to refer to the log entries that have that word. So that, like, if we're doing a category search, if between the vertical bars there was the word disk, we want to know that disk was associated with this particular log entry, or it might be associated with 5 or 6 different log entries. So we can't just say like string to X, because there might be, this disk might be associated with lots of log entries. In the spec it says don't use the multi-versions. They're more confusing and they have less control over them. So instead, what we're going to do is we're going to do a vector of some type that will let us refer to those log entries. Not copies of the log entries, but some way to refer to them. Think about that. When we looked at the excerpt list, remember the excerpt list has to be able to do things like D, B, and E. Delete an entry from the middle, move an entry to the beginning, move an entry to the end. Would a vector where we have to delete something from the middle and insert it at the beginning, would a vector be a good data structure? Probably not. Linked list, we've said, is almost never the answer in 281, leaves us with DEC for the excerpt list. So, when you go through building these pieces, remember we want everything else, the most recent search results, the excerpt list, they should all refer back to the master log file. And if you find yourself when you're writing the code saying, oh, I'm going to have to sort this stuff because it's not sorted, you did something wrong. You either didn't put the right thing in your data structures, the right way to refer to things in the master log file, or you built your preparations at the wrong time. If you prep for the C command or prep for the K command at the wrong time, you might find yourself with results that need sorting before they can be displayed. So take that as a hint that, hey, if I've got to sort here, it means I did something wrong earlier on, and go back and think about what you can do differently. Let's see, what else? Sync with standard IO false. This thing is going to produce big log, it's going to be reading big log files, and it's going to be producing big output files. Got to have sync with standard IO false. And like I said, be willing to do some testing by hand. Run your program with Valgrind to make sure that there's, even if it seems like it's working, make sure there's no hidden uninitialized variable usage that you didn't take into account. Running with Valgrind and a debug build can reveal those problems. So we're just about out of time here. I think I've covered everything I wanted to cover. Hopefully this will help you get started with the project, and will hopefully cut down on our office hours times for everyone. I'll see you in office hours.